Okay, this is proof number 11. First of all, we have the given. Given is that 1 and 2 are supplements. However, they're not really related to each other. They're not corresponding, alternate, interior, consecutive, anything. So I'm going to label angle 3 right here. And now if I look at those locations, I could say that the measure of angle 1 is equal to the measure of angle 3 by the vertical angle theorem. And then, since 1 and 3 are equal to each other, I can make a substitution and change this statement. Instead of saying that 1 and 2 are supplements, I can now say angle 3 and angle 2 are supplements. And that is a substitution of steps 1 and 2. 1 is where I got the fact from. 2 is where I plug that into that equation or that expression. Then, since angle 3 and angle 2 are supplements to each other, that's actually going to help us. Their location is significant. Since 3 and 2 are supplements, I can say now that L is parallel to K, and that's the consecutive interior angle converse. Since those consecutive interior angles are supplementary to each other, that means those lines must be parallel. Okay, here's proof number 12. We're given that measure of angle 1 is equal to measure of angle 2. J is parallel to K, and H is parallel to J. First, since J is parallel to K, that means that with this transversal S that we can use, I can say that angle 2 is equal to that angle 3. And that's because they're alternate exterior angles, so that's the alternate exterior angle theorem. It's a theorem because we had parallel lines and we're using the parallel lines to get the alternate exterior equal. Since H is parallel to J, I could put angle 4, say, right here. And measure of angle 1 equals measure of angle 4. And it's for that same reason. So really, I can keep this in statement number 2 then. Okay, moving forward. Since we know from the given that 1 is equal to 2, and we can make some connections here. Let's see. 4 equals 1, 1 equals 2, 2 equals 3. So measure of angle 4 equals measure of angle 3. That's the transitive property. And then we'll look at their locations. Notice, here's angle 4. Here is angle 3. And those are alternate interior angles to each other. So since those alternate interior angles are equal, we can use the alternate interior angle converse to say that R is parallel to S. And here is proof number 13. We have the given again. Measure of angle 3 equals measure of angle 4. And because those corresponding angles are equal, I can say that L is parallel to M, and that is the corresponding angles converse. Because the corresponding angles are equal, I can say that L is parallel to M. Now going forward from that, since L and M are parallel to each other, I can now say the measure of angle 1 is equal to the measure of angle 2, because parallel means that those alternate interior angles must be equal to each other, and this is the alternate interior angle theorem. Now notice the slight differences between what we're saying. In step number 2, we have the converse, where we're using the fact that since these corresponding angles are equal, we can say that L is parallel to M. In step number 3, we're using a theorem. Since these lines are now parallel from what we have in step number 2, we can say angles 1 and 2, those alternate interior angles, are equal by the theorem. So the converse allows us to say that lines are parallel. The theorem uses properties of those parallel lines and transversals to say that angles are equal or sometimes supplementary.